Welcome back everybody, this is Waste back with another video on the channel. I'm really excited to bring you a crash course for Kubernetes. Kubernetes is a portable, extensible, open source platform for managing containerized workload and services. So what Kubernetes can do for you? With modern web services, users expect applications to be available 24/7, and developers expect to deploy new changes or new versions of those applications several times a day. So containerizing that package will help to achieve that goals. And Kubernetes helps you to make sure that containerized applications run where and when you want, and help them to find resources, tools they need to work. Kubernetes is a production-ready open source platform. In this crash course, I will teach you concepts around Kubernetes and also will walk you through how to create a Kubernetes cluster, deploy an app, explore your app, expose the app publicly, scale up your application, and update your application. Before we start our tutorial, I want to say subscribe to the channel and give this video a thumbs up. Also, if there is any development work required, you can contact me via my business email, which is in the description of this video. Without further ado, let's get started with Kubernetes Crash Course 2021. The best way to learn any technology is by following the official documentation. So here we have this Kubernetes documentation. The link for that is kubernetes.io/doc/home. And in this website, you'll find everything that you need to know about Kubernetes. We're going to start by learning how do we set up Kubernetes cluster locally by using a tool called a Minikube. Let's do that next. Let's go to the terminal. If you're on Linux, open your terminal, Windows, open command line, and you're going to type Cubectl -- version. And as you can see, we don't have a Cubectl installed. If I type Minikube -- version, I don't have a Minikube installed as well. On the macOS, it's fairly simple to install Minikube by using brew install Minikube, and that's the command. Now you might be wondering where I'm getting this command from. So we're going back to documentation. You're going to go to tasks, install tools, and here you find out how to install Cdl on Linux, Mac, and Windows. And here we have this Minikube. I'm going to click on that. It's going to take me to this documentation where you will go get started and select your operating system architecture, because macOS has this Apple Silicon, which is ARM64 based, and you can also install by using binary or homebrew. So I'm going to click on homebrew, and here's the command for installing Minikube. So let's go back to terminal, and I'm going to install Minikube by using brew install Minikube. And if you're on a Mac and you've done some development, I'm pretty sure you already have this homebrew installed. Next, we are going to install Cubectl. I'm going to use brew install Cubectl command, and it's going to install Cubectl for us. Okay, so we got Kubernetes CLI install. Let's verify that by using a command Cubectl version, and there you go, we have the Cubectl installed. Let's talk about container runtimes. You need to install container runtime into each node in the cluster so that pod can run there. I know we haven't talked about these concepts, but we will. Just bear in mind that you're going to need a container runtime, and there are different types of container runtime available for different operating systems. I'm going to take you to Minikube documentation, and here we are in drivers page. Now here you can see there are a list of drivers available for Linux, macOS, and for Windows. Now the preferred one is going to be Docker. As you can see, it's on the documentation as well. Docker is basically a way to containerize your application, and I've already got Docker desktop running on a Mac. So if you haven't have this Docker running, then you need to install that. On Linux, you can install Docker by using snap package. So it's simply snap install Docker. On the Mac, you have to download the package, or you can install by using brew. So brew install --cask Docker. And on the Windows, go ahead and download Docker by following this link. Once you have a Docker installed, then we're going to use some commands from Minikube. So to be able to start the cluster, we only need this command. Let's go to the terminal and type Minikube start. It'll take a few minutes before you can have your dashboard up and running. Now at this stage, we got our tools installed, and also we created a cluster using Minikube. Have the cluster created. Let's verify that by opening Docker, and you'll see we got this Minikube, and in the images we also have this gcr.io. So this is like the default image that Minikube uses to run a cluster. And to be able to see what's going on with the cluster, you can basically type Minikube status, and you will see we have a Minikube running. A type is a control plane, it's running, host, kubelet, API server, and kube config. For additional insights into your cluster state, Minikube bundles the Kubernetes Dashboard allow you to get easily take a look at your environment. Look at some documentation for dashboard. So we'll go to homepage for Kubernetes documentation. We're going to go to task, and you're going to click on access application in a cluster, and you get to see this web UI dashboard. Click on that, and you'll see it'll tell you all about dashboard. So it says dashboard is a web-based Kubernetes user interface. You can use dashboard to deploy containerized application to a Kubernetes cluster, troubleshoot your containerized application, and manage your cluster resources. So this is going to be your source of truth. You're going to be looking at the dashboard a lot, and Minikube allows you to open it up very, very easily. We also have some commands like Cube Cdl based commands that you can use, but they are a bit lengthy and we'll talk about them later. So for now, we only need Minikube dashboard command. Now we can verify that our control plane, host, kubelets, all the services running. So simply type Minikube dashboard on a terminal, and it is going to enable dashboard for us, and it's going to basically give us a link where we can access dashboard. So it says opening HTTP. Now it opened in a default page, so we'll just copy, let's say copy this bit, copy that, and let's go to the page and paste it there, and we should see the dashboard. There you go. So that's Kubernetes dashboard. You can see your workloads on the left, services, config storage, and clusters. I understand we haven't talked about the concepts yet. We are going to talk about them like in a bit, but let's get our environment set up first so we can refer back to what I'm talking about, which makes it easy for you to understand instead of me just explaining concept, not showing you what exactly that is in the dashboard or in Kubernetes itself. So yeah, at this stage, we have all the Kubernetes components installed, and we have our dashboard up and running using Minikube. When you access dashboard with empty cluster, you will see the welcome page. And this page contains a link to this document as well as to deploy your first application. So here it says deploy a containerized application, or select a different namespace, or take the dashboard tour. And that's what we're doing right now. Now, deploying containerized application can be done from a dashboard. So we can simply create and deploy containerized application as a deployment and optional service with a simple wizard. Let's go and click on this plus button here. We click on that, and here in the form, I can specify JSON or YAML, and we'll take a look at the reference for this in a bit, but let's try creating a service from a form. So click on this button here, and then from here you have to specify app name. So name for your application is mandatory. It's a label with a name will be added to your deployment and service if any. Next, we have a container image. Well, this is also mandatory, the URL for a public Docker container image on any registry, or a private image commonly hosted on Google Container Registry or a Docker Hub. The container image specification must end with a colon. We also have this number of pods options. This is the target number of pods you want your application to be deployed in. The value must be in the positive integer. We have a service option. So in the service option, we have two things, internal or external. So we can have internal service or external service. Next, we can also show some advanced options like label. We also have, if we want to put this into different namespace, if you want to run any command, or you want to specify the CPU cores that you want to allocate to it. Let's click on cancel button to get out from this view. On the sidebar, we have different options. It's basically a navigation within your dashboard. So Kubernetes objects defined in a cluster dashboard shows them in the initial view. By default, only objects from the default namespace are shown, and this can be changed using the namespace selector located in the navigation menu. So right on the top here, we have this navigation menu, and here I'm going to click on this little arrow that gives me all the namespaces. Okay, if I click here and I say, show me the Kubernetes dashboard, and you will see now your workload status, deployments, pods. We're not going to go into details of these options right now because we haven't talked about some concepts, but just quickly show you what are the other navigations that you can use. So we got this workload area. So it shows all the application running in a selected namespace. This will list application by workload kind. For example, deployment, replica set, stateful sets, etc. And each workload kind can be viewed separately as well. We have this services section. Well, this shows Kubernetes resources that allow for exposing services to external world and discovering them within a cluster. I'm going to click on service, and right now in Kubernetes Dashboard, we have two services, Dashboard Metrics Scraper and Kubernetes Dashboards. You can see their IP as well, internal endpoints, and right now there's no external endpoints. We cannot access these externally. So let's go to the next one, which is storage. And config and storage shows persistent volume claim resources, which is used by the application for storing data. This config maps, which shows all the Kubernetes resources that are used for live configuration of application running in cluster. Next section is for cluster, and when I click on that, you'll see a lot of different options for your cluster. We're not going to talk about them right now because we need to talk about some common concepts in Kubernetes. So yeah, that was a quick introduction about Kubernetes Dashboard. Let's take a look at a documentation of some concepts in Kubernetes. So in Kubernetes.io, in documentation section, you go to concepts and click on overview. Click on what is Kubernetes. This page provides information about Kubernetes and also tells us how Kubernetes helps us in the deployment world. So I would highly recommend to take a look at this article. I could actually go and create a nice animated spreadsheet to explain this, but I think the best way to learn this concept is by following the official documentation. And information about these three types of deployment is listed here, and you're more than welcome to read from here. Now, I could explain to you, but I think that's pretty much the waste of time. I want to keep this tutorial hands-on. Here is a guide for why you need Kubernetes and what it can do for you. Let me show you a few pages for some other concepts in Kubernetes. You click on Kubernetes Components, and this page or this article will explain to you how Kubernetes work. What are the components of Kubernetes? For example, what is control plane? What is Kube API server, etcd, and Kube scheduler? And we have other components like node components. We have kubelets, kube proxy. Again, I mentioned that already that I could create a spreadsheet and then, to explain to you, but that's not what I want to do in this tutorial. I want to guide you where you can go and explore more and learn more about Kubernetes, and you don't have to really watch any other video after watching this video because here's the information. And if you prefer watching video instead of reading it, then it's going to take more time for you to learn Kubernetes. Let's quickly take a look at this diagram. So here's a diagram which mentions about Kubernetes cluster architecture. So in this, we have a control plane, we have this cloud provider API, and we got these nodes. Got all the documentations down below for each component. Control plane component makes global decision about cluster, such as detecting and responding to cluster events. For example, starting up a new pod. We also have node. Let's take a look at what it says about nodes. So node components run on every node, maintaining running pods and providing Kubernetes runtime environment. Kubelet, it's an agent run on each node in a cluster. It makes sure that containers are running in a pod. So yeah, I'm not going to read it for you. You can go ahead and read it. It's got a lot of information. For example, here's the information for the dashboard as well. Let's take a look at Kubernetes API. Now in Kubernetes API, you can basically use the REST API to modify or maintain or administer your cluster. We also have something called Cube Cdl. So most operations can be performed through Cube Cdl command line interface or other command line tools like Cube which in turn use the API. So here's a plain REST API for Kubernetes, but I don't think you're going to need to use that because I prefer using this Cube Cdl to perform actions on Kubernetes cluster. Here's information about Kubernetes Objects. We're going to need to read this, understanding Kubernetes Object. We will explain to you different parts of Kubernetes Objects available in that. Now, mostly, when you're going to define Kubernetes Object, you're going to need this YAML file. We'll take a look at where is the reference for this YAML file, but for now, take a look at this article, which will help you understand the objects in Kubernetes. Let's go to the next section, where we have this management information. Don't worry about this too much for now, video's just starting out. Let's go to namespaces. Now also in our dashboard, we have something called namespaces. When I click on all namespaces, what is a namespace? Well, in the documentation, it will tell you here, Kubernetes supports multiple virtual clusters backed by the same physical cluster. And these virtual clusters are called namespaces. Makes sense? Very, very simple. And if you want to have some in-details information, then you can continue reading on this. For example, Cdl get namespace. So if we go to command line, I'm going to go and create a new terminal window. We will type Cdl, get namespaces, enter, and you will see the list of namespaces here. The same namespaces are available in the dashboard as well. So let's click on this drop down and you can see default, Cube node lease, Cube public, and these are just a virtual cluster within this physical cluster. Okay, makes sense? Very easy. Now, some other information about namespaces and DNS, take a look at this as well. But when you're just starting out, don't worry about these things too much. We also have some other information about labels and selectors at this stage. Don't need to go into details for these annotations, don't need to take a look at them now. But later on, when you get hands-on experience with Kubernetes, always refer to these articles and take a look at what they actually mean. So let's go to cluster architecture. Now this is another very, very important chapter. In this, you need to make sure you read all these 4 articles. I'm going to explain quickly nodes. So Kubernetes run your workload by placing containers into pods to run nodes. A node may be virtual or physical machine depending on the cluster, and each node is managed by control plane and contains services necessary to run the pod. Now here, there's going to be a lot of information for me to read out to you, which is not really useful. So I would highly recommend take a look at this article as well. So basically, if we remember, for example, I'm going to go and open this in a new tab, overview. Let's go to the overview, and we're going to go to Kubernetes Components. And now you can see in this diagram, we had nodes. So this is what it's talking about. So as you can see, within these nodes, we have services running, whether it is your custom application or an application which is required to run Kubernetes cluster. So when you run your application in Kubernetes, you will see a node running a pod. A pod is just like a Docker container, but in Kubernetes language, it's called pod. So you will see a lot of pods within the node. Let's go back to nodes. So take a look at this, and there are some common commands that will be listed in this article as well. Next article will explain to us control plane node communications. Very, very important article as well. It'll probably take 5 minutes for you to read through, and you will become a master about control plane node communication. Hey, I'm back on the camera. I wanted to talk to you face to face, all right? Now, I've been referencing to documentation. You might not like this style of teaching, but let me tell you, all the mature developers or DevOps engineer, when they try to learn new technology, they always learn from official documentations. They don't go and watch YouTube videos to learn new technologies, because sometimes YouTube videos can take a lot of time to learn something which can be learned very, very quickly from official documentation. And this is a walkthrough of how you go and explore official documentation and learn from it. We're obviously going to perform some practical tasks such as running an application in our cluster and making it available to the public. All that tasks will come, but let's explore some more documentation and way around your documentation and some of the most important articles that you need to learn or you need to read as a beginner, which will get you up and running with all the concepts around it. So that's the goal, because I could create a lot of spreadsheet, a nice animated spreadsheet, which will end up being deprecated in about a year because Kubernetes will change something and then that video cannot be updated. But because I'm referencing to official documentation, this video is never going to get deprecated because documentation is going to get updated, and it might have a different navigation, but it's going to be there. So yeah, this is a different style of teaching, and I think this is the best style because referencing to official documentation is the way to learn new things. Now let's go to some more concepts, controllers. And this is another very important concept you need to learn. Then we go to containers. Now we've been talking about containers, but this is where you are going to learn about containers. Very, very small. So each container that you run is repeatable. The standardization of having dependencies, including, means that you get the same behavior whenever you want. So this is basically a Docker concept. So it's like a Docker concept that you have containers which is isolated from your main operating system and runs in Docker. So let's go to images, and you need to know how to create Docker images. I will show you quickly in a practical way, but if you want to learn in details about what are an image, how do you learn to create images, and there's different information around Kubernetes with images. So container environment is another important one, runtime class, and container lifecycle hook. Now, anybody out there who have watched the YouTube video to learn Kubernetes, if I ask him what is a container lifecycle hook, they might not remember it because it's from the video. When you read from a documentation, you're not going to forget it, or even if you forget it, it's easier to come back and read what you need from here. Okay, so there are other concepts like workload, services, load balancing. So pretty much all of these pages are important, but don't go and start reading the whole thing right now. As a beginner, just read about workloads, services, load balancing, and don't need to go to the whole thing. Just read about service and also about ingress and egress controller. Okay, these are things you need to learn. Basically, read from documentation and you will understand. And basically, this documentation will guide you where to go next and learn more from this documentation. Now, we also need a storage. This is another one that you need to take a look at, because whenever you run a container, it is going to require a storage as well, which we have different types of storage, like volumes, persistent volumes. We got this volume snapshots. Now, the difference between these types of volumes will help you understand, what to use when. So yeah, take a look at that. Then we are going to look at this cluster administration. This is another very, very important. You will be able to create a cluster, and you will come to the point where you have to administrate. You have to, maybe create some certificates or manage resources. Let me go to this managing resources documentation. You can skip other documentation, maybe not, but if you skip this one, you're not going to be able to get anything from this video. So take a look at this documentation. This article basically will teach you how to organize resources, how to write this YAML file, and also talk about bulk operation in Cdl actually. So here are a bunch of the commands or the reference to the YAML file that we defined to define our resources in our cluster. So take a look at this. Then we have some other information, for example, logging architecture. Sometimes you have a problem with your application and you don't have a way to find out what is the problem. The only way you can take a look at is by looking at logs. So the way you look at logs is listed here. Take a look at that as well. Here's a diagram for that. For example, here's my pod running. It's an app container, and it's a standard output to this log file. And then you can also read that from log rotate. So yeah, information is here, guys. Trust me, when you learn from official documentation, you will master the technology. So yeah, enough about documentation. I've shown you the basics of documentation, that what you need to learn. Back in the terminal, we have this URL to access the dashboard. Now we're going to take a look at some of the common operations that you can use on Kubernetes cluster using a minikube. So I'm going to press Ctrl C, and I'm going to start by using minikube delete --all. Alright, so it deleted minikube in Docker, and it's removing minikube machines, and it also removed all the traces of minikube cluster. Let's type clear, enter, and we're going to create a new cluster. I'm going to type minikube start space -- nodes equal to 2, enter, which is going to create 2 nodes for us. Our cluster is ready. I'm going to show you another command that will give us information about cluster, which is Cubectl cluster-info. Enter, and you can see we have this Kubernetes master node, which is running at this URL, and we got this Kubedns is running on this URL. So this is the URL for our dashboard as well. You can also start the minikube dashboard by typing minikube dashboard, and we've already seen this command, but this time if I press enter, it's going to open in a default browser. And if you don't want to do that, you just want to grab the URL, you can type -- URL, and that will give you a URL for your minikube dashboard. We are going to create a deployment using Cubectl. So the learning objective for this section would be, once we have the Kubernetes cluster running as we have, we can deploy our containerized application on the top of it. To do so, we create a Kubernetes deployment configuration. A deployment instructs Kubernetes how to create an update instance of your application. Once we get a deployment, the Kubernetes control plane schedules the application instance included in that deployment to run on an individual node in the cluster. Let's clear the terminal. I'm going to start by typing Cubectl get nodes. Now this command is going to give us all the nodes available in our cluster. So we have this minikube cluster and minikube-m02. It is a control plane master node, and this is going to be our worker node. To deploy our application, we need an image for that. Right now we're using Docker as our container runtime, so we're going to have a Docker image. Go to Docker Hub. We have a lot of public images available in Docker Hub. So from here, we're going to be using a simple Google Kubernetes Bootcamp image. And let's go back to terminal. Now we can create a deployment by using Cube Ctl, create deployment, and specify the name for your application. We are going to use k-b space -- image equal to, and you need to specify the URL for your image if it's hosted on a private registry. If it's in a Docker Hub, you just type the name. I'm using the name directly because I'm using Docker as a runtime, so that's why it's going to be okay. Otherwise, if it's in the private registry, you have to specify the full URL, and there might be another things that, like, how do we authenticate? So that's basically out of the scope of the video. Let's understand how do we create a deployment. We're going to press return, and now it says deployment.apps kb created. Now to be able to look at, we are going to type Cube Ctl get deployments, and now you can see name k-b, it's ready. Right now our application is running in one of the pod within the node. Pods that are running inside Kubernetes or running on a private isolated network. By default, they are visible from other pods and services within the same Kubernetes cluster, but not outside that network. When we use Cubectl, we are interacting with it through API endpoint to communicate with our applications. We will cover the other options, how to expose your application outside the Kubernetes cluster, but for now, let's take a look at how do we use a proxy to be able to connect to our application running in this cluster. I'm going to paste one command, which is going to be this command. Enter. And this command is basically coming from a documentation. So I'm going to press enter. And now you can see it says starting proxy. After starting, we'll output a response. Please click the first terminal tab. Basically, we have our proxy running on this URL. Now I'm going to create a new terminal, and I'm going to type curl and not this command but the proxy. So I will use http / let's say localhost / 8001 -version. Okay, let's go back and verify that's the proxy. Yeah, that's localhost, port is 8001, so that should work. Enter, and now you can see we're getting the response from our application. Says major, minor, git version, commit, build date, compiler, and a platform. So yeah, you can communicate with your service or application running in this cluster by this endpoint. Next, let's take a look at how we expose application to the public. Verify that our application is running. So I'm going to type Cubectl get pods, and we can see our application is running. We'll type another command, Cubectl get services. We have a service called Kubernetes that is created by default when Minikube starts the cluster. To create a new service and expose it to external traffic, we will use the expose command with node port as parameter. Start by typing a command which will expose our application to the public. So we'll start by typing Cubectl, and the command we're going to use is expose deployment / Kubernetes Bootcamp, and the type would be node port, so capital N port. We're going to specify the port that we want to use to make it available. So just say 8888, I'll press enter, and now it says Kubernetes Service Bootcamp exposed. To find out what port was open externally, we will use the command describe service. So Cubectl describe services / Kubernetes Bootcamp. Enter, and you will see the port for it. So that's 8888. So far, we have been using terminal to create cluster, to talk to a cluster using Cube Cdl command. In actual world, when you're going to set up your Kubernetes cluster with many of the services, it's very hard to create those services just using command line. For that, Kubernetes provides a configuration file. Basically, it's a YAML file. To set up YAML files, we can use VS Code with an extension called Kubernetes. So if you go to extensions, you will search for Kubernetes and you get to this one, which is built by Microsoft. So you gotta make sure you use this one. And once you install this one, you get to see this button here. All right, I'm gonna click on that button there. You can see we have a mini cube running our clusters. We can click on nodes to see nodes and namespaces, workloads, network storage. So pretty much all the things that dashboard shows you, this Kubernetes extension will show you that as well. So we got one master node and we got this minikube M02. That's our worker node. Now let's go to File Explorer and I'm going to create a new file called example.yaml. Now instead of just start typing everything in configuration, I'm just going to say Kubernetes, and you'll see some of the suggestion. And if I don't type anything, I'll press Control Space, and here you can see it is giving us some options to start from. For example, if we want to do a deployment or want to do a service. So let's start by doing a deployment. I'm going to select the deployment, and it's going to give me this boilerplate code. Let me zoom in a bit so we can see them. So here we have some configurations. The first option is API version, which basically is the version of API that we're targeting. Next is the kind. So we are using deployment because we are going to deploy some application. Then we have some metadata for application. So here we got this my app, and I'm going to change that to, let's say, my test app. All right. I'm going to copy this and paste that here, and for the container name, let's just change that as well. We're also going to specify a label. So that is an object, so let's do labels, and this label is going to take app.kubernetes.io/name, and we can simply say it's an example. Let's save the file. Next, we're going to specify how many replicas we want to run for these applications. Right now, it's going to just run on one, but just before the selector, we can specify replicas, and I'm going to say do a 5. It's going to run a 5 pods for us. Then we're going to set selectors, match labels, and this is okay. We can just keep that as my test app. Within the selector, I'm going to copy the label, and I'm going to just paste that here because we're trying to match this with the label in the metadata. Next, inside the templates, we got labels, and here we can change a label. And let's just copy this one, so I'm going to use it here for the label. Let's save the file, and now we're going to get inside the containers. First of all, we need to specify the name of the container. So I'm just saying here is my test app. Okay. And the image, we're going to use just a basic Docker image, which is hello world. Then we have ports. And to export the ports, we're going to use just 8080. Okay. Now, once done, then we're going to open a terminal. And inside the terminal, I'm going to just check Cube Cdl is available by checking its version. Yes, it is available. Now, we've created this file. We want Cubectl to read this file and apply this configuration into our cluster. Right now, we are in a default cluster, which is running in a Docker, and we verified that here as well. It's at the minikube and default namespace. So to do that, there's a Cubectl apply command -f which is a flag to specify the file name, and the file would be example.java. Now let's say if I pressed enter here, it is going to read the file and it says deployment created. So that's really good. Now we're going to stick to command line for some more time. We're going to use a command to take a look at the deployment. Use Cubectl get deployments and the name of the applications, actually the name of the container, which is my test app. I'm just going to copy that from there because we forgot to remove these two pp. Enter, and it says error from servers, steps not found. So something is not right. If we take a look at our cluster in Kubernetes extension, we are going to go to deployments and here my test app. So the thing is, it's been deployed, but for some reason here it says app, like actual 2Ps, but it's actually not. So let's change that to 2P, and then there you go. So you have your my test app running. Okay, it is up to date. It's got 0/5, means it is actually trying to create the replicas, and it's basically 0 ready out of 5 for now. If we click here, as you can see here, it is actually creating. I'm going to quickly go to terminal, and I'm going to use Minikube and a dashboard. Okay, that's going to run our dashboard. And if we go to our all workspaces, we're going to go to deployments. So here we have our deployments, and we have this my test app. Click on that, and then here you'll see the new replicas, 5/5 pods. Click on that again, and you can see the 5 pods, but for some reason these 5 pods have a lot of issues. If I click on that, okay, it says backup restarting failed container. Well, that's fine. There's more configuration that we'll have to do. You can take a look at the logs here, okay? And next we are going to go back to VS Code, and let's take a look at the describe command. I'm gonna use a terminal for that. I'm gonna need tab, and I'm gonna use Cubectl get deployments. My test app, and I'm gonna change the get to describe. Enter. And here you have information about your application running. We can also create a service object that exposes the deployment. We can use the Cubectl command, which is Cubectl expose deployment, and that will be my test app -- type equal to, this time I'm going to use load balancer type -- name equal to my service. Enter. It says service has been exposed. Okay, that's good. Now let's take a look at that service. So Cubectl describe services, and name my service would be my service. And here you can see we've got the target port 8080, and we also have some information about this, and the type is load balancer. All right. Next up, we are going to take a look at the pods now. So Cubectl get pods, and I'm going to just output them with wide. We got some information about pods here. So here is the important one. You take a look at this ready column, it says 0/1, 0/1. So these pods are not actually running. And we have the status as well, which says crash loop back off. So something is wrong with our file. And I did that on purpose to show you how do you update this. So if we go to take a look at what image we're using this hello world image, which basically does not exist. correct image would be this one. So I want to start typing that image gcr.io/google-samples/node hello and version is 1.0. And that's basically our image. Now, how do we make changes? How do we apply these changes to our cluster? That is very simple. You just go to Cubectl apply-f example, enter. That's pretty much it. It says configured, so that means it has updated according to your configuration. Now, take a look at our deployment in the dashboard. I'm going to go to test stack, go to replicas, and now you see what's happening here. It is starting our replica. So 3 desired, 3 pending. If you take a look at the VS Code, here we said 5, but let's wait for this to finish. Now, I did that basically 35 seconds ago, so we're gonna have to wait for these pods to finish. So if I click on these 3 dots and go take a look at logs, and you can see exactly what's happening into that container. You notice that we have desired set to 5 now. There are 3 replicas running for this, and now you can see desired 5 and a running 5. Now, how do we test our application? Well, to test our application is pretty simple. We're going to go to terminal, and in the terminal, let's clear it, and I'm going to take a look at the service first. So Cubectl describe services my service. And now if you take a look at here, we have this something called endpoint. Okay, and every replica set has an endpoint. We also need to export our service using load balancer. We'll use Cubectl command, expose, deployment, my test app, and type would be load balancer. And we can name our service as my service. Enter. And it says error from server, it is already exposed. That's good. If we take a look at our Cubectl get services, and we're going to get this my service. Now here you can see it has this external IP, which is a status of pending. The reason for that, if this service is pending, is because we use the type load balancer, and load balancer is not available when you're using a minikube to run your cluster. So to be able to access this service, we need to use this minikube service command and the name of the service. Well, if you're running your cluster on AWS or on Google Cloud, you should be able to use load balancer, but that's not part of this course. So I'm going to press enter, and you will see it is going to open up a browser with hello Kubernetes. So as you can see now, we are able to access our application using this command minikube service my service. The reason for that is because we use this type load balancer. Let me take you to documentation and take a look at where this information came from. So if you go to minikube documentation here in accessing apps, you'll see here it explains what is a node pods, and it talks about a load balancer here. So it says a load balancer service is a standard way to expose a service to the internet. With this method, each service gets its own IP address. To be able to use a load balancer, we need to follow this guide. We need to use this minikube tunnel command. So far, we have used this YAML file, and we ran this Hello Kubernetes image, which is just this one. This is just a sample image. We exported the service, and we could access our application. Now, here is a minikube documentation. So if you want to take a look at what options are available in minikube, you are more than welcome to take a look at those as well. Lastly, I want to show you the specification for this YAML file. So far, we've used very less tags within this YAML file. But you might be wondering, where do you learn more about these tags and what's available in Kubernetes YAML files? Let me take you to documentation, and here I have this link open, which is Kubernetes API. And on this link, you can find pretty much everything that you need to know about this YAML file configuration. And I drop a link for this in the description of this video, so take a look at that. It is basically a raw specification of API version 1.21.0, which means this version v1 that we're using in our YAML file. So yeah, if you like this tutorial, please give this video a thumbs up, subscribe to the channel, and I'll talk to you guys in the next video. Cheers, bye.